Welcome to my office. In this video, I'm going to be reviewing, analyzing, and critiquing the last project from the previous 5 videos, which was a Hexagon murrine chipstack composed of hexagon pieces, which were composed of triangles, which were composed of bullseyes, squeezed and flattened and assembled together. Overall, the project, it went okay. An object was produced. It was not a complete failure. And for a first set of videos, it wasn't that bad. So let's get started. Here's the object that was produced. It's not one of my better ones, and I'm not sure if I'm even going to build a stand for it. I might just put it in the History Museum and remember it as a warning for what not to do. But enough of the negativity. Let's talk about what went right. A lot of things went right. First off, I was able to demonstrate the use of the Inkwala and the hand torch for constructing bullseye murrine. I started by using stainless safety wire to hold together a stack of color rods with a center color core and then 6 other contrasting colors around it. I twisted the wire to hold the rods in place, making a nice clean little stack, put the stack into an assembly fixture, prepared a punty on the Inkwala, then heated the end of the rod stack, attached the punty, worked a little bit on refining the weld and centering everything up. Then I put the assembly into the Inkwala and started heating the end, because at that time the stack was really only held together by a not really that good weld at the punty and the safety wire. So now I'm heating up the end and going to be paddling a little bit very gently and very slowly to get the thing to stick together well enough. And then as soon as the end is kind of stuck together, I clipped off the safety wire, put it back in the Inkwala, heated it up to the point where it was ready for squeezing, did the final heating by hand, and then went off to the squeezer to compact the pieces together and to drive the air out. Only the center core was made this way. The outer layers on top of the core were done with striping. The squeezer is using the iris style dies that can squeeze any size, but they do produce a little bit of sliding distortion. Now I'm moving the Inkwala into striping position, putting it into position mode so that the foot pedal starts and stops rotation. And I'm using the Mirage hand torch to do the striping with the next color. I really like this method. It feels a whole lot like welding, and since I'm a welder, it really makes sense for me. I realize that many glassworkers find the traditional method of using a bench torch to be comfortable because they've practiced it for thousands of hours. But for me, this feels more natural. The traditional method kind of feels like trying to do an oil painting with the brush clamped in a vise and moving the canvas. So here I am, mostly applying heat to the rod and trying to not overheat the substrate, trying not to boil the color, which is a problem that I had throughout this process because I selected colors that were rather difficult to work with, and to be quite honest, I don't have the skill that I would like in working with difficult colors, but the video at least shows very clearly the technique of using a hand torch and the Inquala. When all the stripes are finished, I rotate the head back to horizontal, put the Inquala into rotation mode, and then round off the outside layer using the paddle, keeping the punty cool, and if necessary, reversing direction to control twist. Using this method, I'm able to produce a very smooth and uniform cylinder with the color at a fairly uniform thickness. The assembly of the bullseye components into a triangular piece also went well. Some of the components were made on camera, some of the components were made off camera. Most of the bullseyes were round, but one of them was flattened. Here I am taking the center core section, which is the 5-layer bullseye that I made in the first video, heating it up, and putting it into a special set of squeezer dies to kind of squeeze 2 lobes into it, 2 grooves, and then into these grooves I'm going to insert a rod, about a 10 millimeter diameter bullseye rod, using the Inquala and the hand torch. Once again, I find this method to be very comfortable and very intuitive, and it produces good results for me. I continue the assembly using a smaller piece of bullseye murrine and a smaller torch, this time striping with the bullseye murrine to kind of fill up the little acute angle in the space between the larger rod and the core. This also feels really natural to me, very comfortable, and I think the results come out really well. Then I use a combination of heating in the Inquala and heating by hand, and squeeze the piece into shape using fixed size dies. The fixed size dies don't produce distortion because they move in a straight line directly toward the center, but you have to use the right size dies for the piece you're making. Heating and squeezing a little bit at a time, the piece is finally formed into a nice uniform triangle shape. Do a tiny little bit of touch-up by hand on the benchtop marver, and then pull. Unfortunately, because of camera problems, the pull was not part of the video. I was also able to demonstrate how the Inquala, squeezer, and hand torch could be used to resize the triangle pieces that I had pulled in the previous section. After they were cut to the appropriate length, I was able to precisely squeeze them so that they were all the same size and they all had nice sharp corners, sharper and more geometrically correct than they were when they were originally pulled. Then I put the 6 triangle pieces together, once again using stainless safety wire, prepared a punty, preheated the triangle pieces in the kiln, attached the punty, inspected, made sure everything was on center, and then put it in the Inquala to start heating. At this point, it needed a little bit of extra security, so I welded just a few little dots onto the end to keep it under control before cutting the safety wire. Little bit by little bit, The piece was gently heated. A heat base was built. The heat was soaked down into the core, and the piece was squeezed a little bit at a time using fixed size dies in order to reduce distortion. Then at the end, the piece was pulled down into a smaller size. I was also able to demonstrate Chipstack Assembly using the prototype Chipstack Assembly fixture. Here the pieces are in the fixture, being held in place by the screws and graphite rods, being heated with a hand torch, and carefully pressed into shape with a small graphite tool. This method works really well for Chipstack Assembly, and I want to pursue this a little further and see where the technology leads. And finally, I got a lot of good practice making these videos. I'm using a 4-camera setup and doing it all myself, and there was a lot of things to think about, a lot of things to prepare, a lot of problems to solve, and then at the end I had to edit after improvising narration while doing glasswork that was right on the edge of my skill level. So even though I have no doubt the videos will improve in the future, I think that for a first attempt, this wasn't that bad at all. Now on to the bad news. A whole lot of things went really wrong. The first problem that I had was I chose the wrong colors. Either that or I didn't have the skill to use the colors that I chose. In particular, North Star Skyline just turned out terrible. As much as I was thinking about being careful, talking about being careful, and being as careful as my skill level allowed, it still boiled and bubbled, and the result is just full of holes. The most serious bubble problem was a mysterious, unexplained air pocket that extended through more than half of the final hexagon piece, and I ended up pretty much throwing it away. Even though I used fixed size dies and tried to be pretty careful while squeezing, the triangles did not squeeze as nicely as I would have liked them to squeeze. The pattern was distorted a little bit toward the end of the construction. I believe this was caused by squeezing too soon and not allowing the glass to cool on the surface a tiny bit before applying full squeezing pressure. I've had better luck with other patterns, and hopefully I'll have better luck in the future. Also, I pulled the hexagon a little bit smaller than I would have liked. I was aiming for a larger hexagon section, and my pulling technique just was not quite up to the challenge. I have no doubt that I'll improve in the next one. Even though I was thinking about being careful and being gentle and talking about how important it was to be careful and gentle, I ended up boiling some of the sensitive colors during the chipstack operation. The components were not quite as bad as the final result, so I believe that much of the damage occurred during the chip stacking. And once again, every failure is a chance to learn and a chance to improve. And finally, there were technical problems. Doing a 4-camera shoot with one guy while improvising narration and doing complex glasswork, it's really hard. And the cameras didn't help. They were fighting me every step of the way. In particular, the Sony still camera can do video, but it has an annoying tendency to shut itself off. I had battery problems, I had memory card problems, I had lots of problems, but I learned, and the next videos will certainly get better. I seriously considered abandoning this series of videos and deleting them, and then I thought about it and decided, hey, that's what happened on that day, at that time. It's part of history, and maybe somebody out there can learn from my mistakes, and maybe it'll improve their glasswork. So, thanks for watching.